This is lesson 8.4 on rectangles. Should be a relatively easy lesson because rectangles are essentially just a special version of a parallelogram. The definition is given here, a quadrilateral with 4 right angles. This is enough to prove that every rectangle is a parallelogram. Given that consecutive angles are supplementary, you can prove that opposite sides are parallel. And since both pairs of opposite sides are parallel, we know it's a parallelogram, so it passes on one of our tests. So again, the only thing special so far about a rectangle is that all angles are right angles. Again, because it's a parallelogram, all of these things are true, just as we know about other parallelograms. The only thing that's different, in addition to the 4 right angles, has to do with the diagonals, and that is they are congruent. So in this situation, MR and AT are the same length. What's so nice about this is that we can pretty much look at any rectangle and see that the diagonals are congruent. So again, I encourage you to memorize this. You should write down this theorem, but at the same time, realize that that reminding yourself shouldn't be too difficult. Alright, to the examples. This example on the left, I tell you that it's a rectangle. So automatically you know everything that's true for a parallelogram is true for this. In addition, you know that the 4 angles are right angles, and you know that the diagonals are congruent. In this situation, they tell us the length of SR and a UF. Clearly, you can see that these are the diagonals. Because this is a rectangle, we know that they are congruent. We set them equal to each other and solve for x. I subtracted 6x and then I added 4 to both sides. Once that is done, if we wish to answer this question, what's up, we would need to find the length of UF. I did that by plugging in x is 8 into this expression, or into this equation for UF. It's 52. Moreover, we know that UP is exactly half of UF because in all parallelograms, the diagonals bisect each other. This next question, again I tell you that it's a rectangle. This time I give you different information. Instead of telling you about the lengths of the sides, or the diagonals rather, I tell you about angle measures. I have 3 angles here to begin with, and you'll see that the relationships between them vary. I'll notice initially that 6y plus 2 and 3x plus 2 are alternate interior angles. Because SU and FR are parallel, that means these 2 angles are congruent. I've stated that here, but I ran into a bit of a roadblock because I have 2 different variables. So I go look at these other 2 angles here. Now, again, this is a rectangle. That means this angle is 90 degrees. So I add 5x plus 8 and 3x plus 2 to get 90. Clean it up, that's 8x plus 10. I subtract 10, 8x equals 80, and I divide by 8, so x is 10. This is important because I can plug it in to the equation that I first noted. So this is actually equal to 32. I subtract 2 from both sides and divide by 6 and find the length of y. This word problem is actually something that's quite applicable in real life. When installing, for example, a screen door, it comes with a rectangular frame, or rather, well, it's pretty much a rectangle, but when you install the door frame, it has a little bit of give, and so it can actually sway, and it can become out of shape. It can become no longer a rectangle, I guess you'd say. You do know, however, that as soon as you open the box, that the top and the bottom of the door are the same length, and the left side and the right side are the same length. And so you know that it's a parallelogram to begin with. By measuring the diagonals, what you're simply doing is proving that your parallelogram is in fact a rectangle. That's how you know you have 90-degree angles. Okay, we're going to end up with 2 more examples, and they're going to feature the same rectangle. We're calling it bank, or quadrilateral bank. We want to see if it's a rectangle. As with parallelograms, or just general parallelograms, we have ways of testing to see if bank is a rectangle. Since they told us to use the slope formula, we're going to use the definition of rectangle. That is, a quadrilateral that has 4 right angles. To see if we have 4 right angles, we simply need to measure the slopes of all 4 sides, as I've done. This will be the more difficult part of the problem. Basically, can you do the algebra correctly? The basic computations. Once I've done that, you can see that BA is perpendicular to side AN and side NK, which is to say it's a right angle. That angle A is a right angle N is a right angle. Because these two are perpendicular, you can see that angle K is a right angle, and because these two are perpendicular, you can see angle B is a right angle. So it is 4 right angles, and therefore it is a rectangle. I will remind you at this point that slopes of perpendicular lines are opposite reciprocals. That's how we know these are lines are perpendicular. Finally, perhaps I could be asked the same question, and this time use the distance formula to determine if bank is a rectangle. Well, because we're not using the definition, that is, we're not proving that the 4 sides or the 4 angles are right angles, we're going to first need to prove that bank is a parallelogram. We did this in the last lesson. You'll remember you measure all 4 sides and make sure opposite sides are congruent. So, I believe that if you were to do this, you would find the same thing I do, that BA and NK are both equal to the square root of 40, and that AN and BK are both equal to the square root of 10. So we know the sides, opposite sides are congruent, therefore we know it's a parallelogram. And at this point, we need only to show that the diagonals are congruent. Again, using the distance formula, I measure the diagonal BN and the diagonal AK, determine that they're both the square root of 50. So I know that bank is a rectangle.